Everybody got your test in front of you? Engine Performance 2, Test 2? You got that?
This one?
No, Engine Performance 2, Test 2. Read the words. We got it? All right. Engine Performance 2, Test 2. Everybody got one? You got one? You got one. You got one, Adam?
I'm looking.
You got one?
Yeah.
You got one.
Yep.
Everybody got the same pack of papers, so don't be shaking your head and saying you ain't got it. All right. It's gonna be back in the stack. That it? You got it? Flip back in your stack. You found it? That's the one. Let's start on it. Technician A says module communications networks are used to reduce the number of wires in a vehicle. Technician B says communications network is used to share data from sensors, which can be used by many different modules. That's not a hard question to answer.
B only.
That is actually, no, it's actually C. You're going to have fewer wires in a vehicle if you're using communication network because you're sharing information between modules. And I was talking about that when we were talking about emissions, how you can capture the vehicle speed signal from the speed sensors and harvest it from the ABS module and let the PCM and whatever other modules. What all you need vehicle speed information for? You need it for cruise control. You need it for engine controller, so it'll know transmission shift information. You also need it for what? What about the instrument cluster? And what about the ones that turn the radio up louder whenever you're going faster? What about the ones that change the body controller changes the intermittent wiper speed when you're going faster? Let's see what we got here. Goodness gracious, Bobby. Yeah, that's probably going to work okay. I think I can live with that.
Okay.
That'll work.
Now them right there is a little bit longer because they didn't have one that size.
Yeah, all right.
All right.
All right, let's see what we can do to make that happen. All right. A module is also known as a what?
Node.
It's going to be a node. That's right. Hey, you knew the answer to that one, didn't you? A high-speed CAN bus. What's CAN stand for? You know, controller area network, right? High-speed CAN bus communicates with a scan tool through which terminals? I know you would have to remember that one. That's got to be 6 and 14, right? Which would be A. Okay. UART uses a signal that toggles between 0 volts and what?
5.
Listen to that, girl. 0 and 5 volts. UART, yep. GM Class 2 communication toggles between what?
B.
0 and 7.
Yeah. B.
0 and 7 volts. Which terminal is the data link connectors that the General Motors use for Class 2 communication? That's going to be B. What we've got here, incidentally, there is a breakout box that I have for the data link. It'll work on any car that's got a standard, OBD2 connector. And if you're wanting to scope those patterns that you get, as soon as you plug in, you can actually plug this breakout box into your data link, and you can plug your scan tool into the breakout box, and then you've got little banana outlets where you can check all of the, bus terminals and everything, and get in there with your tool and see if it's talking. And that's kind of important to understand that. One of the things that you guys are supposed to learn how to do this semester is determine how to fix a vehicle that won't talk to you. You know what I mean? Now, we're all thinking about plugging our scan tools in, right? We're going to plug our scan tool in, we're going to get information, we're going to, check our data, we're going to sort it out, and then we're going to fix the vehicle. But what happens if you plug the scan tool in? What's the first thing you're going to do? This is important. I'm not just talking wind here. I plug my scan tool in, it won't even power up.
Fuse.
Huh?
Fuse.
Which fuse?
I don't know which fuse, but that's on my truck.
Yeah, that's what
The cigarette light.
Bingo, look at that, listen to him. And that's pin, which pin is it on the data link connector?
I don't know what pin it is.
Pin 16. We'll probably come across the question in a minute. Pin 16 is supposed to be hot. Now, if you look at your data link connector, if you look into it, now watch this, your data link connector is shaped like that. But it's got 8 terminals on the top and 8 terminals on the bottom. This one here is 16, right? Okay, these two here that are right next to each other in the middle are 4 and 5, they're ground. So on every data link connector, 4 and 5 are ground, 16's hot. Pretty simple, right? But what if your scan tool hooks up, boots up, you select your vehicle? Now, incidentally, on GM cars, you better select the right vehicle or it ain't talking to you. If you got a GM car that's not talking to you, back up, make sure you pick the right vehicle. If you've got any other vehicle that's not talking to you, realize that, well, like for instance, some vehicles will actually have a little bus that's got all the networks passing through it. When you unplug it, it's made for diagnosing the networks to see which ones may have broken wires or whatever. And if that's unplugged and somebody left it unplugged, you ain't talking to nobody. Basically, you're not talking to no module. But what if you've got a shorted module that has the whole network down, a whole segment of the network down? You're gonna have to determine which module has got it shorted. You know, if you start unplugging modules and you all of a sudden you unplug one of the modules that you see on the network and all the rest of them wake up, see what I mean? Network diagnostics is a big deal nowadays because these cars have got sprawling network spidering out all over them. And if you get to where you can understand that, you're a whole lot better off. All right, now right here, that's why you kind of got to understand is GM LAN is the General Motors term for what type of module communication? That's the high-speed CAN network. LAN typically stands for local area network. Can CAN H and CAN L operate how?
All of the above.
All of the above. CAN H is at 2.5 volts when not transmitting. CAN H goes 3.5 volts when transmitting. CAN L is at 2.5 volts when not transmitting. Now there are high and low speed networks. That's what we're talking about. The high speed networks. Whenever I put this number here, 500. No, not 550. 500. What's that? What am I talking about when I say
Kilowatts per second.
kilobits?
Kilobits.
You just multiplied it by a factor of 8. Kilobits per second. All right. Now, this is the high-speed network, you know, that I'm familiar with. And then you have a lower speed network that's like 87 kilobits per second. Now, your older networks are usually down below 50 kilobits per second. But the long and the short of it is this network stuff that you're going to have the high-speed network on. What do you think needs to operate? What do you think needs to use the fastest network? What's the critical stuff that has to use the fastest network in order to operate?
Imagine, I don't know, camshaft, crankshaft position sensors?
Well, actually, your engine controller is basically on the network. Furthermore, you've got your vehicle dynamic stuff. Anti-lock brakes has got to work in nanoseconds. You know, so you got to actually have a really high-speed network. The stuff that's not quite as critical is going to operate on your, you know, like your audio stuff and all that kind of thing. It doesn't have to operate all that fast. So they basically they have the networks broken up. And then some of them will have CAN networks, and they'll also have the older kind of networks that are talking a lot slower. So you'll have several networks on the same car. Which terminal of the OBD2 data link connector is the signal ground for all vehicles?
4.
That's good. That was it. You know, you got 4 and 5 are both grounds, but 4 is the signal ground. Terminal 16 of the data link connector is used for what?
Is that the 12 volt positive?
12 volt positive. That's right. I was just talking about that. And technician A says a breakout box can be used to access the bus terminals while a scan tool is used to activate the modules. Technician B says 38 cavity diagnostic connectors found on many BMW and Mercedes vehicles under the hood.
I'm pretty sure he's
Both of those guys are right. Now, what's a breakout box?
It's that thing that you got where you can connect like little banana wire plug things to different terminals and do stuff with it.
Yeah. Ordinarily, I'm just throwing this to simplify it. Your engine control module, all right, look up here. Your engine control module is got to have, would ordinarily be plugged in here. And you got all these wires going out to your engine. All right, and then a couple of these are network wires, there's grounds, there's powers, there's stuff going to sensors, a lot of it. It's got parallel and serial. But you're going to go in between here with something that will plug in just like that does, and it's coming out here to a box, and it's got a bunch of numbered terminals on it that correspond with the numbers, the test pins on the module. That way you can actually take your meter or your scope or whatever and hook into there, and it's not a lot of trouble. Now, having a breakout box for every car is just not feasible. I bought one so that we would have one so you'd know what a breakout box was. But if you try to buy a breakout box, costs $500, $600, $700, $800. You know what I mean? So, but anyway, that's a handy thing to have. Now that's a breakout box for the engine controller. The little breakout box for your OBD2, if you're going to be serious about doing this, you need to get one of those for your toolbox. A little breakout box. Since we're talking about engine performance, you also need to get a little injector pulse tester too, like I'm going to show you guys here in a little one of these days. Which terminal? Wait a minute. Never mind. Technician A says the breakout box can be used to access. We've already talked about that too. Never mind. Let's go to question number 12. The process of sending multiple signals of information at the same time over a signal wire and then separating the signals at the receiving end is called what?
Multiplexing.
Multiplexing. Remember, it's kind of like having a one-lane dirt road or a four-lane highway. You know, parallel interfaces got everybody going at the same time. Serial interfaces whenever you're just having to sort the data out as it comes. Now, this is what's cool about these network stuff. Every module gets all the data on its network, but it knows what data to ignore and what data to pay attention to. It's sort of mind-boggling if you think about it. Low-speed networks operate at less than how many bits per second?
10,000.
5,000.
Who said 10,000, 5,000? At 10,000, less than 10,000. The UART data bus operates at a baud rate of what?
8192.
8192. You already been reading the book or something? Wow, that rascal. She's answering questions left and right. Which of these commonly designated D2B is an optical bus system connecting audio, video, computer, and telephone components in a single ring structure with a speed of up to 5,600,000 bits per second? That's fast, isn't it? Domestic digital bus. How do they use networks in factories? You know? What do they use them for? You guys ever been to an auto assembly plant?
Programmable logic controllers.
Huh?
Programmable logic controllers.
Well, some of the stuff they do is programmable logic controllers, but imagine what happens here. You've got these cars coming down the assembly line, and you got to get this big dashboard that's got the cluster and all the wires dangling out of it, and it's and all this kind of stuff. And you're backing a truck up there, and you plug a network cable into that truck. Okay, as the car is coming along, the dashboard for that particular car is coming off the truck just as that car comes along. And then they, there's a machine that the dashboard weighs about 150 pounds, and they don't need people handling that. So they got a robot that picks the dashboard up. It goes over here, it takes a picture, it goes in, it takes another picture, it sets the dash in there, and when it moves on down the assembly line, the guy gets down there and he goes, the dash that we struggle to pull off, it's actually popped in there in about 6 minutes, and everything's plugged in and tightened up. But when you do the same thing over and over and over and over and over again, you get really fast at it. See what I mean? They're hanging, the wires are dangling there, and they know this goes here, 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 and here. Occasionally they leave a ground wire loose or something, and you got issues.
I imagine it's a lot easier when you have a windshield put into place and everything else.
Yeah, well, when I was looking at the one on that one, the windshield was in there. And the ones when I was at the Hyundai plant. Now I don't know how to look at that. We're gonna have to load up one day and go to the Hyundai plant and go through that plant.
I was about to suggest that. That's the one that's on the way to Montgomery, right?
Yeah, it's easy to do. I got to set it up and tell them who's coming. It's not just as simple as showing up and say, hey, we're going to do a tour. What you do, they got to call ahead. You got to say, I'm bringing this person, this person, this person, this person. They got to know who's coming by your name and all that kind of stuff. And then we go up there on a 15-passenger van, which I'm licensed to drive a commercial, chauffeur license. And we go up there and we get on this little cart and we go through the assembly plant and we watch them, do all this stuff. It's pretty neat. Basically the guy's talking to over your headset, and it's got a little train that goes through there. And
yeah, I know our class I want to do 8th grade.
yeah. I went through the assembly plant for. This is something else. I'm talking about networking too. When I went to the engine, the Power Stroke engine plant up there in Indianapolis 3 or 4 times, and they actually don't use any air tools in that plant at all. Did you know that? Every tool they use is electric, and the reason they use electric is because the computer can keep up with how many bolts turns there are and how much torque was put on it by measuring the amps and how many commutator pulses, and you know what I'm saying? It knows, and every engine has got its own paper trail, so that it can actually, if there's a problem that happened, if it blew a head gasket or whatever, they can pull that number for that engine and pull the paperwork out of the computer that came with it and tell, well, this bolt right here only turned 10 turns and the rest of them turn 13. You see, and so something was in that hole. You know what I mean? Yeah, it's really cool stuff how they do that. But they use electric tools for that because you cannot count the turns and the torque on an air tool. I mean, you can't have your computer can't do that. You know, basically. But anyway, all this stuff is happening really fast. But what I was getting at, the just-in-time delivery is what's pretty amazing, because it seems to me like this truck's got to come from another place and back up to that plant just as the cars are coming along, and the dashboards that are on there are the ones for each car coming along. Think about that. What if this guy stubbed his toe or had a flat? You know, he'd shut everything down. You know. All right, so let's go on down here. Let's see.
See,
16 is B, yes, there you go. Which terminal LBD 2 data link connectors, chassis ground.
Yeah, because I thought the other one was 5, not 4, and this one's supposed to be 4.
he said the other one was 4.
Was the other one was 4?
I mean, that's what I said, and you said
The
yep.
signal ground, I thought it was 5 though.
Never mind, 4 and 5 are gonna be ground, just for the ground. I don't know, I didn't write this test. All right, but I mean, basically the answer according to them is supposed to be 4, but I think it's easy to get those 2 pins crossed up because they're both black wires and they go there. I'm gonna tell you this too, this is really interesting, but watch this. I had this Ford Escort, 97 model, OBD2, and the lady said, sometimes my speedometer don't work and my transmission won't shift. Got me? Are we together now? Sometimes the transmission won't work and it won't shift. Okay, so I said, okay, I go in here and I get a vehicle speed sensor code, and I look, and the last mechanic that worked on it was doing something else, but he happened to notice the transmission wouldn't shift. And he put a vehicle speed sensor on it, and when he drove it around the shop, it was working, and he thought he was done. They got in and got ready to leave, speedometer's dead, transmission won't shift. So I get it back in there. So I hooked up to my data link under there with my scope, and I got a pattern, you know, but even though the scan tool wouldn't talk. The scan tool would boot up, but it wouldn't talk to nobody. And what happened was, I got to checking, and I found out that pin 4 or 5, I can't remember which one it was not grounded. And it came directly from the negative battery terminal, and they had a bunch of little wires coming off the negative battery terminal, and one of them went to that. And so the vehicle speed sensor circuit wasn't grounded, neither was the scan tool, and all that, and it was all because of a ground at the battery. See what I mean? You can actually beat your head against the wall. And I did all kind of measuring voltages and everything. I wrote an article about that for Motor Age. But anyway, that's basically, see, the scan tool wouldn't talk, but you also had to. And one of these days, I'm going to throw you guys a bug on one of the cars out there. And you're going to find out that the scan tool won't talk, the engine won't start. And you may have seen one, when you try to crank the car, the wipers start going. So be ready for that, okay? You going to be ready for it? All right then. Which one of these is a version of bat flat and a high-speed serial communication system for in-vehicle networks?
A?
What'd you say?
A?
A. Flex-ray bus. That sounds like something from the 1950s, didn't it? All right.
What is 17?
17. Oh, I'm sorry. Number 17 is B. OBD1 Ford. Now that's another story there. Donnie was working on his van. It was OBD1 Ford. Not all OBD1 Fords had data stream. They started having data stream in '88 on OBD1 Fords and Lincoln Continental. But he said, I got this van that's giving me a hard time, and it puffs out a bunch of black smoke when it first starts up in the morning, and I don't have data stream, so I can't look at anything, and I'm just so disgusted because it won't throw me any kind of an OBD1 code. And I looked at the OBD1 connector, and I said, this thing's got data stream on it. He goes, no, it don't. I said, yeah, it does, because it's got these other 2 wires going to it. And he said, well, it told me it didn't have it. And I said, well, tell it you got a E4OD transmission instead of an AOD. He said, well, that's not what it's got. And I said, I don't care. Tell it you got that. Lie to the tool. So he lied to the tool. He got data stream, found out the throttle position sensor voltage was dancing. Ta-da. Well, see, just looking at that OBD1 connector, if you've got those data stream wires, you have data stream if the wires are there. If you don't have data stream, the wires won't be there. The Bronco doesn't have it, and it's OBD1, and the Escort does. See? All right, so Mustangs didn't have data stream until 1994. Ticked me off. Here we got the, let's see, Technician A says a candy module will flash the red LED rapidly if communication is detected. Technician B says a twisted pair is where 2 wires are twisted to prevent electromagnetic radiation from affecting the signals passing through the wires. Who's right about that?
B's definitely right.
Well, that's actually a B. Yeah, that's what that is. Technician A says Chrysler OBD 81 and 95 vehicles were equipped with a bus system called Serial Communications Interface. Now, the cool thing about computer, I'm not going to call them acronyms because they're not acronyms unless they spell a word, abbreviations, is you will find that SCI, Adam, have you ever seen SCI in the,
I've seen SCSI.
yeah, SCI, SCSI, but there's SCI, Scalable Component Interface is what it stands for in the regular computer world. And this one here is called Serial Communications Interface, but they use SCI for both of them. Same way with Candy. You look up Candy, and it's that way too. It's got different things. Technician B says a Chrysler Programmable Controller Interface is a 3-wire communication protocol that connects an OBD2 DLC at Terminal 2, which technician is correct. A is the only one correct about that. And you know what Chrysler called their bus when they first started putting buses on cars? They called it a, see if you can figure out what this stands for. They call it a CCD bus. Never guessed what that means in a million years. It stands for Chrysler Collision Detection. Has nothing to do with having an accident. It has everything to do with sorting out the signals. You know, because they got packets crashing and all that stuff. So basically, they got to be able to sort those signals out and route those over here and those over there and all that kind of. And that's the old bus. I mean, that's the old bus thing, but that became sort of old hat for buses later on to be doing that. So whenever you guys have to start, huh?
19.
Oh, did I miss 19? Sorry about that. A single wire serial communications protocol that uses one master control module and many slave modules is called what?
See?
That's Motorola Interconnect. But also, think about this, the network that talks to the GEM module on these Fords is a single wire network. And the Chrysler PCI bus is a single wire network. So some networks are single wire networks and some are double wire networks. Some of them, even if you cut one of the wires, will still talk. Because it's sort of a redundant thing. But anyway, anybody got any questions about that?